So this video is to introduce the entire problem-solving map for stoichiometry problems. We know already that we can get from moles to moles if we're working with a balanced chemical equation. We took a look at getting from mass to moles of the given, and then moles to moles of the required, and then getting back to the mass of the required. And now we just want to make sure we could get from particles as well, if that's what we're given. And when we worked with looking at moles, we took a look at that these are all the same representation of the same physical quantity. So if we were looking at sodium chloride and we had an amount in a beaker, if it was 0.5 moles of that substance in the beaker, that would be the same thing as 3.01 times 10 to the 23 particles, because that's half of Avogadro's number, and we can convert between the mole and the particles using Avogadro's number. And this physical amount of mass, if we're looking at it, is also the same as half the molar mass of sodium chloride of 29.2 grams. So this amount of matter on our scale is the same. 29.2 grams is 3.01 times 10 to the 23 particles, and it also is 0.5 moles of sodium chloride. So we can just use this side of our map to convert between all of those. So this is for our given, and we can do the same thing for our required. So this full map is great. The steps all remain the same to solve a problem. The ones that we already looked at for doing mass to mass is all the same. Step 1, make sure you've got a balanced chemical equation. Step 2, from that balanced chemical equation and the written problem, identify your given and required. And again, that's only ever going to be two particles in the equation, two of the molecules, two of the elements, whatever your equation involves. And then you just ignore all the rest of whatever's in that equation. There could be 3 reactants, there could be 5 products. You're only going to be looking at 2 of those things in total. Then identify your known values that you already should know that probably aren't given in the problem. So identify your molar masses, and again, you only need them for the given and the required that you're working with, and Avogadro's number. You need to remember all of those. Step 4, just figure out where you're starting and change your given to moles. Step 5, going through the heart of our problem solving, getting the moles of your required from the moles of your given using your balanced chemical equation. And then step 6, take the moles, go back to the problem, see what they required. If they required moles, you're done. And if they didn't, if they wanted it reported in either mass or particles, you just have to convert that physical quantity from reporting it in moles to reporting it in particles or mass. So if we were to take a look at a problem that gave you a given in particles and had a required in mass. So they gave you an amount of one substance in particles, and they wanted to know the amount of the required substance in mass. You just have to take a look at your map, figure out where you're starting. All right, well, our given is in particles, so we're going to start there. We're going to convert through Avogadro's number to moles of the given. We're going to convert through our molar ratio from the balanced chemical equation to moles of required. Go back, what did we want? Oh, we wanted mass. All right, so then we go this way and we convert the moles of required to the mass of required using the molar mass of the required. And then effectively, as far as your map is concerned, for that problem, you're just ignoring that one and that one. You just don't need those parts of the map. And if we take a look at a different problem and follow this route slightly differently, all right, so if we take a look at a problem where the given is in particles and they also want the required in particles, it is always easier to go through the mole ratio. So please always just take the route through here. All right, so go from particles to moles, because again, you're given, your starting point is particles. Always, 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 you do that, convert through the molar ratio, take a look back to your problem. Our required is also in particles, so then we follow the route down this way, going from the moles of the required back to the particles of required using Avogadro's number to do that conversion. And then again, we're just going to ignore parts of our equation. We're going to ignore that part. we're going to ignore that part. We don't need it for that problem. We're just going to do particles to moles, moles to moles, and moles to particles. And so problem solving any stoichiometry problem is just as simple as identifying where you're starting on this little map, where you're going, and then following all the same steps. And then you are done. So that's it.